Hello, welcome. So, if you're new to the channel, kindly subscribe and please kindly visit the previous video so for your better understanding. So, in this tutorial, we'll be learning about the Bode plot. So what exactly the Bode plot represents? Basically, when we are talking about the Bode plot, so this plot represents the frequency response of the system. Frequency response plot. This is basically a sinusoidal frequency response is given to a system, and what is the output response of the system. So this Bode plot represents two functions. One is the magnitude and the angle, and how they are varying against the logarithmic values of the frequency. So we can safely say that frequency response of the Bode plot is a plot. The frequency response plot is a plot of magnitude, basically. Magnitude. Here the magnitude of what? Magnitude of the open loop transfer function, which would be given, see, open loop transfer function was gs of s h of s. So here the value of s would be changed by j omega, that's it. So we can say gj omega hg omega. So this is the open loop transfer function, okay. So a plot of magnitude of open loop transfer function, when, and a phase angle of it, and phase angle of gj omega hj omega, when omega is varied, when omega is varied from 0 to infinity, similar to the root locus concept, wherein you saw the gain k of the open loop transfer function was varied from 0 to infinity, and you got the value of the range of the thing where the system is stable and where it is not stable. So here, so now system would be varied from 0 to infinity. So this, there is a wide range of variations. There is a wide range for system is varied from 0 to infinity with respect to what? With respect to the omega value, with respect to the frequency. So there is a wide range of variations. Hence, it becomes difficult to represent these variations in linear scale. So what we accompany here is that we need a logarithmic scale to represent this. Logarithmic scale is needed. Okay, is needed, and a special kind of plot and a special kind of graph would be required to plot these responses. That graph is called as the semi-log graph. So the semi-log graph. So you have basically the plot of magnitude. Okay, magnitude, that is gj omega hj omega versus the log values of frequency, and your phase angle. Okay, phase angle, that is angle of gj omega hj omega versus log values of frequency. So this x-axis is a logarithmic graph here, wherein y-axis is a normal graph, normal scale. Okay, linear scale. This is a linear scale, wherein this is the magnitude plot, and this is the phase angle plot. So both the plots will be varied in the same, would be represented in the same graph. So let's go to the other thing. So we can say that the magnitude expressed in logarithmic values against logarithmic values of frequency is called as magnitude plot. So we can say that what is magnitude plot? This graph is the magnitude plot, wherein I have drawn, this is the magnitude plot and this is the phase plot. Phase plot. Again, we have done one mistake here, so this should be the logarithmic value. Okay. So magnitude plot is plot expressed in expressed in logarithmic logarithmic values of values against logarithmic values of frequency, that is omega. This is the magnitude. Whereas the phase plot is what? It is basically the phase angle in degrees. Phase angle in degrees represented against what? Represented against logarithmic values of frequency. So this was basically about the Bode plot, what it is. Now in the next lecture, we will see about how it is done. what is a semi-large sheet, and we'll give you an example. So kindly, if you are new to the channel, kindly subscribe it, and we'll be stopping here.